question I was in the last class? Tell me.
On question number 5,
Exercise
8.4.
8.4. Question number
5th.
5th. There are. Okay. So
We
let
have
us.
done the question number 5.
Question number 4, I think we have completed, right? Question number 5, I have to start.
No, we did 5th question.
All the parts? No, not all the parts. I think I did
Yeah.
first, second, third.
Yeah, third we did.
Third we did, right? Yes, Abdullah? Fourth part now. Question number 5th, fourth part.
Okay, ma'am.
1 plus sec A and divided by sec of A is equal to sine square A divided by 1 minus cos of A. So you have to prove. So in this case, we will like simplify both LHS and RHS. Okay. So let us first look at the LHS. 1 plus sec A divided by sec A. So the first thing is to convert everything in sine and cos. So that makes things a bit simpler. So I write it 1 plus sec A. I can write 1 upon cos A, right? And then I have 1 upon cos A. Okay. Now in the numerator, I have fractions, like I'm adding 2 fractions. So I'm going to take LCM, cos of A. So here 1 in the denominator. So 1 into 1, I'll get cos A and plus 1. And then 1 upon cos A. Right, Abdullah?
Yeah, ma'am.
Okay. Now this like outer cos A will be multiplied here and the inner cos A will be multiplied by here. So it will be cos A into cos A plus 1, right? And then divided by 1 into cos of A. Okay. Okay, now this cos A will get cancelled out. So you are getting cos A plus 1. So I think it's quite simple. So let us simplify the RHS now. So RHS is sine square A divided by 1 minus of cos of A, right? Whenever you have sine square or cos square, so always think of the first identity. Now, what is the first identity, Abdullah? Sine square A plus cos square A is equal to 1, right, Sarah?
Yes, ma'am.
So in place of this sine square A, I can write like from here, I get my sine square A as 1 minus cos square A, right? So
Yeah.
whenever you have sine or cos, you can convert it into other by using this identity. So sine square A, I can write 1 minus cos square A and divided by 1 minus cos of A, right? Now, can I write it like this? 1 square minus cos of A whole square divided by 1 minus cos A, right? No problem.
Yes, ma'am.
1 square is 1. Now it has become A square minus B square, Abdullah. What is A square minus B square identity?
1
Yes, Abdullah. A square B minus B square. What is this equal to?
A square minus B square is equals to um, uh, A minus B whole A minus B bracket A minus B into bracket A plus B.
Very good. So A square minus B square can be written as A plus B into A minus B. Okay. So I can write it as 1 minus cos A into 1 plus cos A, right? And
Yes, ma'am.
divided by 1 minus cos A. Now this whole bracket 1 minus cos A, 1 minus cos A will get cancelled out, right? I mean, the whole bracket will get cancelled out. So you will get 1 plus cos A. So you are getting your LHS equal to RHS, correct?
Yes, ma'am.
Written?
No, ma'am. Done, ma'am.
Okay, next part. Fifth part. Now this is cos of A minus sine of A plus 1 and divided by cos of A plus sine of A minus 1 is equal to cosec A plus cot A, right?
Yes, ma'am.
Okay. Now, see, whenever I have cos square A or sine square A, then I can use identity number 1. But when I have simple cos A, sine A, so I cannot do anything, right? So you have to think something else. Now, see the RHS. I want to get cot A, correct, Abdullah? You can see
Yes, ma'am.
a cot in the right hand side. Cot is what?
Yeah.
Cot means cos A divided by sine A, correct?
Yes, ma'am.
Okay, so if I divide this whole thing, like my LHS, numerator and denominator both, by cos A, so I can get one cot, correct?
Yes, ma'am.
Okay, so let us try. So I'm like take LHS first of all, and then dividing numerator, sorry, and denominator by cos of A. So what will happen? Now this is cos of A divided by cos of A minus sine of A divided by cos of A, and then plus 1 upon cos of A. And similarly you do in the denominator. Cos of A divided by cos of A plus sine of A divided by cos of A and minus 1 upon cos of A. So I have divided throughout by cos A, correct?
Yes, ma'am.
Okay, actually the first step is this. Now look here, I'm doing like this, cos of A minus sine of A plus 1, and the whole thing is actually divided by cos A, right, Abdullah? So
Yes, ma'am.
when you have a common denominator, so that means you can break it like this, cos A upon cos A minus sine A upon cos A, correct? Plus 1 upon cos A. So that like if you take LCM again, you will get the same thing, right? So I have directly written, like I have break this cos A. Is that okay? Got the point, both of you?
Yes, ma'am.
If there is any confusion, I mean, don't feel free to ask me, no problem. All right, so now I have 1 minus. Now this sine A upon cos A will become cot of A, correct? So I have got one cot now. Plus 1 upon cos A is sec A, and then divided by, again I get 1 plus another cot of A and minus sec of A. Okay.
Yes, ma'am.
Okay. Now see, I don't want to go back into sine and cos because I already had sine and cos. So I have to think of other identities now. Now what is the second identity? It is 1 plus tan square A is equal to what? Sorry, sec square A, correct? And then you have 1 plus cot square A is equal to cosec square A. So I'll try to use these identities somehow. Is that okay?
Yes, ma'am. It's okay.
Hmm. So let us try to replace this 1. If I use what can I do here? Okay, let me try this one. I mean, from identity number 1. Now look at this identity number 1. So 1 plus tan square A is equal to sec square A, correct? So 1 is equal to sec square A minus of tan square A.
Yes, ma'am.
Or should I use... Okay, let me just try. I mean, you don't write. Let me just see what comes out. So this one, I mean, the numerator one, I'm writing like this. I'm writing sec square A minus of tan square A in the numerator. And then I have minus cot of A plus sec of A. And then divided by 1 plus cot of A minus sec of A. Hmm. No. I mean, what will I get here? There's a mistake. I think cos by sine is tan and cosec. Just give me a minute. See, there's a problem here. I have done, I think, one mistake. Now see here, both of you very carefully see here. Actually, I'm getting like cot A, right? And then I'm getting sec A. Actually, I want to get something which comes in the same identity. Now, cot is coming in identity here and sec is coming in another identity. So I'm getting a wrong combination. Getting the point?
Yes, ma'am.
Yes, if I do it like this, just see the difference. Instead of dividing by cos A, if I divide everything by sine A, right? So
Yeah.
instead of doing this, if I do it like this, cos A divided by sine A, and then minus sine A divided by sine A, and then plus 1 upon sine A, correct? And then divided by same cos A upon sine A plus sine A divided by sine of A and minus 1 upon sine of A, right? So what will I get? Now cos upon sine will become cot of A.
Cosec.
No, cos upon sine is cot, inverse of tan,
Yeah.
right? Okay, minus 1 and then 1 upon sine is cosec.
Cosec.
Yes. Now divided by, now again cos A by sine A is cot A plus 1 and minus cosec A. Fine, Abdullah? Now you can
Yes,
see,
ma'am.
now you can see this cot and cosec are in the same identity. Actually, I want to use some identity, but if I was dividing by cos of A, I was getting cot and sec, and they are not coming in the same identity. But now my cot and sec are coming in the same identity, so I can use this identity here. Got the point?
Yes, ma'am.
Yes. So you don't have to divide by cos A, you will divide by sine of A. Now see, it has become easy. Okay. Now I'm writing here at the top. I think you have already written this line, right? You know the question also. Now I'm using this space. Now see, I am getting, so I can write it as cot of A plus cosec of A and then minus 1 I'm writing here, no problem, just flipping.
Yeah.
And then again, I'm writing cot of A plus 1, okay, let's see, minus of cosec of A. Now in place of this one, I'll write this thing. From identity number 3, you see 1 plus cot square A is equal to cosec square A, right? So the 1 can be written as cosec square A minus cot square A. Fine, Abdullah? So I'm writing it like cot of A plus cosec A minus, now put a bracket because you have minus outside. So write cosec square A minus cot square A. Is that okay, Abdullah? And then you have cot of A plus 1 minus of cosec of A. Yes, Abdullah, I can't
Yeah,
hear you.
ma'am.
Okay. Now take it like this, A square minus B square. So it will become A plus B into A minus B in the next step.
Yeah.
So it will be cot A plus cosec A minus. Now it will be cosec A plus cot A and into cosec A minus cot A. So A plus B into A minus B. And then I have this divided by cot A plus 1 and minus of cosec A. Now please note it down up till here because I'm going to rub it. The blue one I'll rub.
Ma'am, you can rub the blue one.
Okay, so I can rub. Fine, Abdullah, have you written? Okay. Anyway, I was just dividing by sign A. Okay, now look here very carefully. So now see here, this is cot A plus cosec A. Because it's plus, I can put, like, I can combine it together. And then I again have cos A plus cot A here. So this is my term number 1 and this complete is my term number 2. So both the terms are having cot A plus cosec A. So I can take it common. Fine, Abdullah?
Yeah, ma'am.
Yes. So if I take like cot of A plus cosec of A common, right? So in the first term, like here, what will remain? 1. Okay. Minus, and then this bracket will remain. Cosec A minus of cot A. Any problem here in the numerator?
No, ma'am.
Please let me know if there is any sort of confusion. So cot of A plus 1 and minus of cosec A. So I'm not disturbing the denominator. Now let us open this bracket in the numerator. Let's see what I get. Cot A plus cosec A, and here 1 minus. So it will become cosec A and then minus minus plus cot of A, right? And then
Yes.
divided by cot of A plus 1 minus of cosec of A. Now look carefully. This bracket, this bracket is same as this bracket. See, 1 is positive both, cosec is negative in both, and cot is positive in both.
Yes, ma'am.
Yes, Abdullah? So basically,
Yes, ma'am.
this whole bracket and this whole bracket will get cancelled out, right? And you are left with cot of A plus cosec of A, which is equal to your RHS. Yes, written?
Ma'am, 1 minute.
Okay.
Done.
Yes, Abdullah, done. Now see one thing very carefully, both of you. Like there should not be any confusion. For example, I have something like this: 2 minus cot of A and then divided by 3 minus cot of A, right? Let's say. So sometimes a student, what they do is they see both the numerator and denominator having cot A, they cut it like this, right?
Yes.
Getting it? No, you cannot do it. It is not cot. I mean, if you have single cot A by cot A, then you can do it. This is 2 minus cot A, this is 3 minus cot A. You cannot cut cot A from here. Getting the point? Not like this. Like for example, if you have same bracket, let's say you have 2 minus cot A and then divided by something like, let's say 5 into then this same bracket. I mean, this whole bracket is exactly same. Getting it?
Yes, ma'am.
So then you can cut this complete bracket, not just cot A. Getting the point?
Yeah.
Fine, Abdullah? It's a very common mistake. Sometimes students do it. So that is why just please make sure. If the whole bracket is exactly same, then you can cut the complete bracket. But you cannot cut something like this, cot A by cot A. This is wrong. Okay, next part. Sixth one. This is under root 1 plus sine A and divided by 1 minus of sine A. This you have to prove sec A plus tan of A. Okay. Now look at this question, Abdullah. Whenever you have something in square root in the denominator, so what we do to remove square root? Who will tell me? How do we remove square root from the denominator?
By multiplying it with the
The opposite sign. So
yeah.
we rationalize the denominator. That is called rationalizing the denominator. Yes, Abdullah? Okay. Now see the LHS. So if I have something like this, 1 plus sine A and divided by 1 minus sine of A. So first of all, just write it like this, like break the square root. So square root 1 upon sine A and divided by square root 1 minus sine A. So this we can do with square root, right? Now, in the next step, I'm going to rationalize it. So 1 plus sine of A and then divided by 1 minus of sine of A. So I'm going to multiply it with under root 1 plus sine A, correct? And then under root 1 plus sine A. Like the opposite sign, which is in the denominator, we take the opposite sign and then we multiply both numerator and denominator. So this step is called rationalizing. Correct? Okay, so now in the numerator, you can see I have square root. So 1 plus sine A into 1 plus sine A. So I can like bring both of them in the square root. And then now here I have 1 minus sine A into 1 plus sine A. Correct?
Yes, ma'am.
Okay, Abdullah, where are you?
Ma'am, my net is lagging, ma'am. Can you hear me? Okay.
Yes, I can hear you. Right. Okay. Now look here. So I have 1 plus sine A into 1 plus sine A. So basically, like you have a square root and then you have 2. So 1 will come out, like 1 will remain, right?
Yes, ma'am.
Or if I write it like this, 1 plus sine A whole square and then divided by. Now look at the denominator. So this is A plus B into A minus B. So it will become A square minus B square. Got it? 1 square minus sine A whole square. A square minus B square. Correct? A minus B into A plus B. Now this square root and square will actually cancel out. Only 1 plus sine of A will remain. Correct? And then now you have, I can write it like this. Under root 1 minus sine square A, right? Now 1 plus sine A divided by under root. Now from identity number 1, 1 minus sine square A is equal to cos square A, right? So 1 plus sine of A divided by. Now again in the denominator, I have square and then I have square root. So only cos of A will remain. Now what you can do is you can just like break the denominator. So 1 upon cos A plus sine A divided by cos A, right? So 1 upon cos A will become sec A and sine A by cos A will become tan of A. And this is equal to RHS.
Ma'am, can you show the blue part again?
This complete from here?
Yeah.
Okay. Now look at this step, Sarah. So I have just, simply multiplied 1 plus sine A, 1 plus sine A. So 1 plus sine A whole square, 2 times I'm getting, right? And
Yes.
you can see it like this, A minus B into A plus B formula, right? So it will
Yeah.
become A square minus B square. So it will become 1 square minus sine A whole square, correct?
Yeah.
Okay. Now in the numerator, I have square root also and then square also. So they will cancel out. Only 1 plus sine A will remain, correct?
Yeah.
Okay. Then here I can write it like 1 square is 1 minus sine square A. So we write it like this.
Yeah.
Okay. So 1 plus sine of A and divided by square root. Now from identity number 1 minus sine square A will become cos square A.
Correct. Yeah.
So it will become 1 plus sine of A and divided by, so square and square root will get cancelled out. So cos of A will remain, right?
Yeah.
Okay. Now you just break the denominator. You write it like this, 1 upon cos A and plus
And only
sine.
the denominator?
Yes, I'm just splitting the denominator. See,
Okay.
if I again take the LCM, so LCM will be cos A, right? And I'll get 1 plus sine A, right?
Yeah. Yeah.
So I can split my denominator. Okay. Now this 1 upon cos A is sec of A plus sine A by cos A is tan of A.
Tan.
This is RHS.
Done, ma'am.
Okay. I hope Abdullah has also done. Now come at 6th, 7th part. This is sine of theta minus 2 sine cube theta and then divided by 2 cos cube theta minus cos of theta. Okay, and this should come out to be equal to tan of theta. Now you can see both the terms are having sine theta, sine theta. So I can take sine theta common, no problem,
Yeah.
right? So look at RH. First of all, let us take LHS. So you write your LHS sine theta minus 2 sine cube theta divided by 2 cos cube theta minus of cos theta. Okay, so I'm taking sine theta common. So sine theta into 1 minus 2 sine square theta, right? Divided by, same I can take cos theta common and then I'm left with 2 cos square theta minus 1, correct?
Yeah.
Okay. Now what will I do here? I can replace this one by this. Like look at the identity, sine square theta plus cos square theta is equal to 1. So in place of this one, I can write sine square theta plus cos square theta. Any problem?
No, ma'am.
Yes. So from identity number 1, I'm writing it like this, sine theta into, now in place of 1, I'm writing sine square theta plus cos square theta and then minus 2 sine square theta. So use your brackets correctly, carefully. And then cos of theta, and then I have 2 cos square theta minus, now in place of this one, put a bracket, I'm writing cos square theta plus sine square theta, right?
Yes.
Right, Abdullah? Okay, now open the brackets. So sine theta into, this is sine square theta plus cos square theta minus 2 sine square theta, right? And then denominator, this is cos of theta, and this is 2 cos square theta minus of cos square theta, and then plus minus will become minus sine square theta, right?
Yes.
Because you have minus outside, so the signs will get changed. Yeah, both will become minus. Right now, just subtract. So sine theta into. Now you have sine square theta minus 2 sine square theta. So 1 minus 2, how much?
1
1 or minus 1?
minus 1.
Minus 1, right? 2 is greater, so minus 1. So you get minus of sine square theta, right? And then plus cos square theta. Okay. Then divided by, I have cos theta. Now you have 2 cos square theta minus cos square theta. So how many cos square theta will remain? How much is 2 minus 1, Sarah?
Yes, ma'am.
Look at the denominator. Look here. I have 2 cos square theta minus cos square theta. So how many cos square theta will remain?
Cos square theta.
Yes, only one will remain, right? 2 minus 1. Okay. So I have cos square theta and then minus of sine square theta, right?
Yes, ma'am.
Okay. So you can see sine of theta, and then like flip it. I'm writing like cos square theta here and then minus of sine square theta here. No problem.
Yes, ma'am. No.
Okay. Then I have cos of theta and then cos square theta minus of sine square theta, right? Now, please very carefully, don't do this that cos square theta will cancel out cos square theta and sine square. No, that is wrong. I mean, this whole bracket will actually cancel out the whole bracket. Got the point?
Yeah.
So don't do this cos square theta and sine. No, that will be wrong. Right, Abdullah? So be
Yeah,
careful.
ma'am.
Okay, so the whole bracket is exactly same. So the whole bracket is actually canceling out. Okay, so now you have sine theta and divided by cos theta, which is actually equal to tan theta. So this is your RHS. Okay, done.
No, ma'am. 1 minute. Then,
Right. Next part. That is eighth
eight.
one. Okay, now you have sine A plus cosec A whole square and plus cos A plus sac A whole square This you have to show to be equal to 7 plus 10 square A plus quad square A, right? So let us take the LHS. Let us solve my LHS. My LHS is this: sine A plus cosec A whole square plus, then you have cos A plus sec of A whole square, right? Now this is A plus B whole square formula. Now what is the formula? A plus B whole square. Yes, Sarah. What is the identity? Yes, Abdullah. What is A plus B
Ma'am,
whole square? Tell me.
A square plus B square plus 2AB.
Very good. Plus 2AB. So I'm going to expand it like this. So it will become sine square A, right? Plus cosec square A plus 2 into sine A into cosec A, correct?
Yes, ma'am.
Okay, and similarly the second bracket. So it will become cos square A because it's plus, so I'm not putting a bracket, and plus sec square A and then plus 2 cos of A into sec of A, right? So I have opened both brackets by using this identity. Okay, now I can do one thing because all the terms are positive, so I can just,
Ma'am,
yeah. Hmm.
ma'am, what is after like sine square A plus cos sec square A plus
2
2?
sine A into cos A, right? 2AB,
Yes.
A square plus B square plus 2AB,
Yes, ma'am.
right? Okay. Similarly here, A square plus B square plus 2AB. Okay. Now see, all the terms are positive, so I can just shift their positions, no problem. So what will I do here? Now look here carefully. This sine square A and this cos square A. So I'm just writing them together, no problem. Sine
Yes,
square
ma'am.
A plus cos square A. I'm writing it together, then plus. Now I have this term cosec square A here, right? Now look at this term. I'm writing it like this: 2 sine of A, and then cosec will become 1 upon sine A, correct?
Yeah.
Right? Now this cos square is already written. So plus, then I have this sec square A and plus 2 cos of A, and this sec A will become 1 upon cos A, right, Abdullah? Okay, so this sine A and this sine A like actually cancels out. This cos A will get cancel out, right?
Yeah.
Okay, now this sine square A plus cos square A will become 1 if I just combine them together, right?
Yes, ma'am.
Okay, plus then I have cosec square A and then plus 2, only 2 will remain here. 2 into 1, that is 2. Plus you have sec square A and then again you have 2, correct? Right?
One second.
See, here 2 will remain, isn't it?
Yeah.
2 into 1, that is 2. 2 will remain here, right?
Yeah. Yeah.
Okay, okay. Now I have 1 plus, now this cosec square A, I can write 1 plus cot square A from the identity. Third,
Yes.
okay, plus 2 plus. Now this sec square A, I can write 1 plus tan square A from the identity and then plus 2. Right, Abdullah? Okay, so I mean, open the bracket if you want in the next step, or you can directly do it because it's all plus. So 1 plus cot square A plus 2 plus 1 plus tan square A plus 2. Now you add all the numbers together. So 1 plus 1, 2, 4, 5, 6, 7. So you have got 7, right? Plus cot square A and then plus tan square A. So this is your RHS.
Yes, ma'am. Done, ma'am.
Okay. Next part. Then I have ninth. This is cosec A minus sine of A into sec of A minus cos of A. And this you have to show to be equal to 1 upon tan of A plus cot of A, right?
Yes, ma'am.
Okay. So obviously we are going to start from the LHS. Take this cosec A minus of sine of A into sec of A minus of cos of A. So the first thing here will be to convert everything in sine and cos. So everything will become like same, right? So 1 upon cosec can be written as 1 upon sine of A and minus then sine of A, right, Abdullah? Similarly, 1 upon sec will become 1 upon cos A minus cos A. No issues?
No, ma'am.
Okay. Now you take LCM in the first bracket. So LCM will be sine of A, right? Because you have a 1 here. So LCM will be sine of A.
Yes, ma'am.
Okay. So sine A is already there. So you will get 1 here minus now 1
Sine square.
sine square A. Good. Now again, same here. The LCM will be cos of A. And then you get 1 minus cos square A, right? Okay. Now this 1 minus sine square A is cos square A.
Yes, ma'am. Cos square A.
So cos square A from identity, and then you have sine of
Sine
A.
A.
Then into, this is multiplication here, right? Between the
Yeah.
brackets. Now 1 minus cos A is sine square A, and then divided by cos of A.
Square.
Yes?
Yes, ma'am.
So 1 cos in the numerator will get cancelled out. So only cos of A into sine of A will remain, right?
Yes, ma'am.
So I think it cannot be simplified further. So let us simplify the RHS also. So let us try to simplify the RHS and let's see if it is coming out to same or not. So 1 upon tan of A plus cot of A. So again, I'm going to convert it into sine and cos. So it will become like 1 upon tan will become sine A by cos A,
Yeah.
and then this will become cos A by sine A.
Sin
Okay. Now in the denominator you take LCM. So LCM will be cos A into sine A, right?
Yes, ma'am.
So cos is already here. It will become sine square A, correct? And then plus. So sine is already here. It will become cos square A. Yes?
Yes, ma'am.
Okay. So it will become 1 upon. Now sine square A plus cos square A is 1.
Yeah.
And then divided by, you have cos A by sine of A, right? Right?
Yes, ma'am.
Okay. So now this will become, so when you have fraction in the denominator, right? So basically we write it like this, 1 into and then the inverse of the fraction. So it will be cos A sine A divided by 1, isn't it? Or you
Yes, ma'am.
think of it like this 1 is actually 1 upon 1, right? So this will multiply with this and this will multiply with this. So ultimately you will get this, right?
Yeah.
Or what we do it, this, for example, you have 2 into 3 and divided by, let's say, 1 upon 4. So how do we divide? We divide it like this, 2 upon 3. This division will become multiplication and then this will become opposite, reciprocal. This is how we multiply, right?
Yes, ma'am.
Yes, Sarah? So after this step, like if you see, it is actually like 1 upon 1 divided by 1 upon cos A sin A. So basically it will become 1 multiplied by then the reciprocal of the denominator. Correct?
Yes,
So I
ma'am.
hope you have understood. So this is equal to cos A into sin A. So your LHS is equal to RHS. Abdullah, any confusion? Any question?
No, ma'am.
Okay, Sarah, you are having a test of trigonometry on Saturday, right?
Yes, ma'am.
And you have to attempt it.
Yes.
Okay, next question. Written?
No, ma'am. This one.
Okay.
Done, ma'am.
Hmm. Done? Okay. Then 10th part. Okay. Right, Abdullah, this is the last part. Now here, there is no LHS and RHS. Basically, you have three terms which are equating each other. So we will try to solve all of them and we will show that all the three terms are actually equal, right?
Yes, ma'am.
Okay, so let us try the first term. The first one, 1 plus tan square A and then divided by 1 plus cot square A. See, this is direct. Use the identity. 1 plus tan square A is sec square A, right? And 1 plus cot square A is cosec square A, right?
Yeah.
Okay. So 1 upon sec, sorry, sec is 1 upon cos, correct? 1 upon cos square A
By
by, what can I
one
write?
by one by sine square.
Very good. Now this will become like 1 upon cos square A and the denominator fraction will become inverse. So sine square A divided by 1. Is that okay?
Yes, ma'am.
We can write it like this also. So this is sine square A by cos square A. And this is equal to tan square A, right? Sine upon cos
Yeah.
is tan. Okay, so basically this term is coming out to be equal to this one, right? Now let us show the second term also. Second term is 1 minus tan A and then divided by 1 minus cot A whole square. So inside you don't have square. This time the square is outside. So I can write it like
Ma'am,
the
does the question mean like we have to get all of them like tan square A as
basically
answer?
basically these both the terms you have to show equal to tan square A, right?
Okay.
Yeah. So this is 1 minus tan A whole square, right?
Yeah.
So the square is outside now. And similarly 1 minus cot A whole square. So I have just written separately numerator and denominator. So this is A minus B whole square now, right? It will be opened by using the identity A minus B whole square. So it will be A square minus B square and then, sorry, A square plus B square minus 2AB, correct?
Yes, ma'am.
Okay, similarly in the denominator, a minus b whole square. So a square plus b square and minus 2ab. Right, Abdullah? Okay. So this will become 1 plus then tan square a minus 2 tan a, and then divided by 1 plus cot square a minus 2 cot a. Correct?
Yes, ma'am.
Okay. Mm, you have to show it equal to tan square a, right? I think it will become simple if at the first step itself I convert it into sine and cos, right?
Yeah.
Because
Make it.
unnecessarily I have made it complicated. One minus x square a. Okay, let us do it like this. Right, so let us change it into sine and cos first of all, and then try to solve it. So 1 minus tan of a and then divided by 1 minus cot of a whole square, right?
Yeah.
Okay, so 1 minus, now tan of a can be written as sine a by cos a,
Yeah.
and then divided by 1 minus, this is cos
Cos
a by
A.
sine a. So I'm not opening the whole square, right? I'm putting it outside here. Now this will be, let's take LCM. So cos of a will be the LCM, and you get cos of a minus sine of a, right?
Yeah.
And then divided by the LCM is sine of a, and then you get sine of a minus cos of a, and now whole square. Okay.
Yes, ma'am.
So like it will become cos of a minus sine of a, and then divided by cos of a, and the denominator fraction will become inverse, right? Sine of a upon sine of a minus of cos of a. So put brackets because you have minus terms, and then whole square is outside. So don't miss this whole square. All right.
Yeah.
Okay. Okay, write it down up till here.
No, ma'am.
Okay. Now you look at this bracket. This is cos a minus sine a, and this one is sine a minus cos a, right?
Yeah.
So to make it same, like, see, if I take like from here, the first bracket, if I take the minus outside, so the sine term will become plus and the cos term will become minus. So it
Yeah.
will become same as the denominator. Okay. So I'm going to take the minus common. So this whole bracket is outside. Don't miss it. This whole square. Now here I'm taking minus common. So it will become like sine of a will become plus and this cos of a will become minus. No issues?
Yeah, ma'am.
Okay. And then into sine of a you are having, and then divided by cos of a, and then into this bracket sine of a minus cos of a. Now you see this whole bracket actually cancels out, right?
Yeah.
Okay. So you are left with minus sine of a and then divided by cos of a whole square. Now this is minus sine a by cos a is tan of a whole square, right? So
Yes.
when you are taking square, minus into minus will become plus, and this will become tan of square a, right?
Yes, ma'am.
So both the terms are coming out to be equal to tan square A. So you can write like this. The first result you can give name 1 and this you can give name 2, right?
Yeah.
So then you can conclude that from 1 and 2, like from result 1 and 2, this complete, you can write this conclusion that 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A divided by 1 minus cot A whole square is equal to tan square A, right?
Yes, ma'am.
Because you don't have LHS and RHS, so you have to conclude like this. Yes, Abdullah, are you here or you have left?
No, ma'am.
Okay. Now I'm giving you one question. Written, both of you?
Yes, ma'am.
Yes, Abdullah, written?
Yes, ma'am.
Okay, now tell me the answer for this one. Like if you have a triangle ABC, right? And which is right angled at B.
Okay.
Okay. Now I'm giving you that AC is 13 centimeter and AB is 5 centimeter. Now you have to
Okay.
tell me the value of sine of A. Now both
Okay,
of you
ma'am.
will do it.